Namaskar friends, welcome to session 20 in our course on work system design, and today we are going to wind up our discussion of the fourth week. Today is the last session for week 4, and in week 4 our target was to introduce the concept of method study. Now what is method study? Method study is a technique for developing a better method, the best method, the most efficient and effective method of performing the work. How do we do that? We first analyze the current method or the method being followed using the various recording techniques, and then using creativity, using different types of alternatives, analyzing the alternatives, we try to find out one better method or a combination of methods which can help us to do the task in a much efficient and effective manner, productive manner, time saving manner, and causing less injuries to the worker. The method must be safe. So there can be n number of criteria which can guide us towards our endeavor, towards our efforts for developing the better method. So there can be large number of criteria which is a guiding force for developing a better method of doing the work. So just to have a brief glimpse of what we have covered, we have 2 weeks of discussion. We had in fact 2 weeks of discussion on productivity, then 1 week of discussion on work study, the basics of work study, and now we are finishing 1 week of discussion on method study. And in method study, what we have covered till now, we have seen the basic definition. I have just given a layman's definition on work study in today's session. But otherwise we have seen that what is a standard definition of method study. So method study I have introduced today also, but the standard definition was discussed in the very first week, in the very first session of week number 4. We have seen what is method study, what are the application areas. In the second session our target was to learn about the various steps that are followed during the method study approach. And if you remember, in the last session our target was to understand the operation process chart, and before that we have seen in session number 3 what are the various recording techniques that are used for performing the method study. So starting from the basic definition to the application in terms of operation process chart, we have developed the understanding of performing a method study. We by now know what are the various techniques. If I ask you maybe as a short assignment that name any 5 recording techniques that can be used for method study, I think each learner must be able to name at least 5 techniques that can be used. One of them obviously is on your screen, that is the operation process chart. Then there can be flow diagrams, then cyclograph, chronocyclograph, there can be string diagrams, then there can be flow process chart. So there are different types of charts which can be used. So just to have a brief summary of what we have covered in method study till date, we have covered the basic concept, the basic definitions, we have covered the steps involved in performing a systematic method study, we have covered the recording techniques used for performing method study, and we have covered the basic aspects of operation process chart. Now coming on to the operation process chart, we have covered that this will give us a bird's eye view of the operations, inspections, transportations happening inside the factory. So it will give us an overall broader picture of the work being performed, the sequence of operations being performed, as well as we can get an idea the transportation of man and material also. And we have seen in the previous session one standard operation process chart. Today our focus will be to briefly understand that what a operation process chart is in context of the application point of view. So today we will see the examples that can be discussed in order to understand the concept of operation process chart. So let us start our discussion with a household work that maybe most of us may be doing. Develop a process chart for making a sandwich. So for sandwich, what we need to have? We need to have loaves of bread, and then we need to have some cut vegetables, and then we can stack them together, or we can, I am an engineer, so I am calling it stacking. So you can lay up them, or you can place them layer by layer, and you can make a sandwich. Now how sandwich can be made, and what can be the various operations or various processes that have to be followed to make a sandwich, that we will try to see. Now just to revise, what are the various process chart symbols that we use? So circle is used to depict the operation, square is used to depict an inspection, arrow is used to depict a transportation, inverted triangle is used for storage, and which one is the fourth one? I think it must come to your mind. That is very important, that we want to eliminate in our process charts or in our processes. That is the delay. The delay we want to eliminate. So that is represented by a solid D. So these are the 5 process chart symbols that we usually use to draw the networks. Now this is a work at hand. We have to prepare a sandwich. What type of flow chart or what type of process chart will be used, that we will see. So on your screen you can see, as we have seen in the previous session also, the distance and time can also be included in an operation process chart or outline process chart. So here we are having one important thing, that is distance. Symbols I have already revised today. This is for transportation. These symbols are for operation. And here we are using 2 types of symbols only, transportation and operation. So we are not performing any inspection activity. So quickly I will read it for you, the process or the sequence to be followed for making a sandwich. Move to the cabinet, that is the storage space. Get loaf of bread, that is operation. Remove 2 slices of bread, which is again operation. Then lay slices on the countertop, operation. Close loaf of bread, operation. Replace the loaf of bread on shelf, operation. Open butter, spread butter on top slice of the bread. Then, oh sorry, I think I have missed this part. We have a inspection also here. So we have a operation, transportation and inspection. Inspect the sandwich, then move to the serving area, and finally serve the sandwich. So there are 3 process chart symbols being used here. We are using transportation, operation and inspection. Many a time you will see that there will be a particular operation or a activity which you will feel a little doubtful about, that whether I must put it in a operation or I must put it in a transportation. So we have to use our mental faculties, because the activity has to be represented on the chart. And what is our target? Our target is to account for all the operations or the activities happening in the way we are performing the task. So it has to be accounted for, and it may play an important role when you are designing a newer method. So that particular thing has to be accounted for. Even if we are in doubt, we must account for that activity, maybe in operation or in transportation, as per our understanding or as per our way that we think the activity must be represented. So this is just one example. The other example is developing operation process chart for manufacturing of a electric motor. So this is another process chart. So for a electric motor, if all of you may have studied this in basic electrical. So you have a rotor, you have a stator, and you have a main body of the electric motor, and there are the covers. Now you see, turn is represented by a symbol of operation. This is again turn, again represented by symbol of operation. This is inspection, then drilling, then again inspection, represented by a square. On the left hand side, if you remember, it is given empties. So this is maybe the minutes. So the time is also mentioned there, and you can see the various operations and inspections are mentioned. So if we see in the last session, if you remember, we have seen that mostly in operation process charts our focus is on 2 types of symbols. Which are these 2 symbols? Yes, operation and inspection. But in the previous example we have taken, we have liberally used the transportation symbol also. So here we see, and if you remember in the last session we have seen that the main component, the major part or the major compound is taken on the right hand side of the operation process chart. So this is the major component on which the other parts will come and get assembled. This is the major component, and other one are the sub components or sub parts which will be assembled into the main part. And if you see all these three parts, the stator assembly is getting assembled here, your rotor assembly is also coming here, and then your covers are also coming here. So these three parts are getting added into the main line or the main part, that is the body. And then we have seen in the last session, if you remember, a term called buyout. So this is a purchased part which is also entering into the main assembly. So we have a main assembly line in which there are operations and inspections happening. Then there are parts which are also manufactured simultaneously, and they are also having different operations and inspections, and finally we are assembling the complete product. So here we can see, we can represent this is representing operation, this is representing inspection, how many total operations have taken place, what is the frequency, and how many total number of inspections have taken place. So instead of going into the details of each and every operation and each and every inspection, the important point is to understand that how to construct operation process chart. So you can take an example of your own and try to construct operation process chart. So maybe you can think of making a metallic pulley which has a wire wound on it, which is used for taking out water from the well. So what can be the operation, what will be the main part, what will be the sub parts or the sub assemblies which will come and get assembled on the main part. So accordingly you can think of an example and construct a process chart. So let us see, maybe for the body, what are the various, maybe one line we can try to understand. The first one is turn the base, which is operation, turn the bore, which is again operation, turn the ends, again operation, inspection, then drilling, which is again operation, and then again finally the inspection. So all these operations and inspections are there on being done on the body in a sequential manner. Similarly for the stator also operations and inspections are listed. Similarly for rotor, you can see die casting is an operation, then there is an inspection, then assembly of fan, which is an operation, then you do the balancing, which is again an operation. So maybe, and finally the inspection. So for each and every sub part also there are sequence of operations and inspection, and for the main part also there are sequence of operations and inspection. So this way we can construct, and we can also represent the assembly. We have seen there are assembly operations A1, then this is A2, and this is A3. So 3 assemblies are taking place in this case, 3 assembly operations. Now this is the last problem that we want to discuss today. This has been adopted from the book from ILO, Oxford and IBH Publishing Company Private Limited. Now this is you can say, develop a process chart for switch rotor assembly. So the product is a switch rotor assembly. What are the various parts? There is this part which is a stop pin. There is a plastic molding, this part plastic molding. Then there is a spindle, it is already highlighted. So broadly there are 3 parts here. The assembly drawing shows the rotor for a slow make and break switch. So we will see now how, if we say what type of operation process chart will be here. Whatever we have discussed just prior to this, where there was a main body, then rotor, stator, and then there was a cover. How we have constructed, we have seen what is going to be the main part of this product or of this assembly operation, and what are going to be the sub parts. So the main part will be towards the rightmost corner of our operation process chart, and the sub parts or sub assemblies will be on the left, and if there are number of sub assemblies, they will be farther off from the main line. So we have to first identify what is going to be our main part on which we are going to build up the complete product. So let us see how it will look like. Now this is the operation process chart for switch rotor assembly on your screen. So in this case we are taking spindle as our main base on which we are going to assemble the other sub parts. So our plaster molding is getting assembled into the main line, and similarly our stop pin is also getting assembled on the main line. So we are having two assembly operations, one here and the another one here. So this is our, you can say, operation process chart for the switch rotor assembly. Each one of these has further got number of operations and inspections. So you can see here, for the stop pin the material is given, it is steel, and then the different operations are given, operation number 10, 11, then there is an inspection here, two inspections are taking place here, number 5 and number 6, and then there are two operations here. So we can sequence the operations and inspections as they are happening. If you remember, when we have to draw a operation process chart, we must not rely on our memory, we must go and actually observe that how the work is being done and then try to plot it in the form of operation process chart. So here the numbers are given. Now these numbers, these are representing certain operations and inspections. So the broader picture is clear that the main line or the main part we have to identify, and the sub parts or the sub assemblies also have to be identified, and for each one of them we have to see what is the sequence of operations happening, where the inspection is taking place, and then assemble the complete product. So let us take an example, not an example, but from here only we will try to understand that how we have drawn this. I have already explained what I want to say now further, but let us quickly read and try to further reinforce our understanding of the operation process chart. So in making an outline process chart, so we have seen that outline and operation is same. In making an outline process chart, it is usually convenient to start with vertical line down the right hand side, vertical line down the right hand side. If this is the vertical line down the right hand side of our operation process chart of the page, and it shows the operations and inspections undergone by the, now I have called it as the main part, but as per our slide we can also call it as a principal unit or component of the assembly. So whatever is going to be the base, the principal component of the assembly, that we can start from the right hand side vertically down in our operation process chart. And or a compound in a chemical, this is another example. So suppose it is a chemical reaction, we want to draw operation process chart, so that can be, it can be a compound in case of a chemical process. In our case, what we have taken? We have taken the spindle. So if you see, we have taken here spindle, that is the main principal component, and that we are drawing on the right hand side of our operation process chart. The time allowed per piece in hours is shown on the left of each operation. So you can see, if we go back to our this operation process chart, here we can see this is representing the time that is taken for each and every operation and inspection. And if you can see that for inspection we are saying no time. So why no time? That we will try to see in our subsequent slides. No specific time is allowed for inspection, it is already highlighted, as the inspectors are on the time work, on time work. So they are already present there. The operations and inspections carried out on the spindle, which is made from 10 millimeter diameter steel rod, are as follows. Now if you go back, just try to go back to our slide. If you see, here only numbers are given, number 1, 2, 3, 4, 5, 6. So operations are given here, but we do not know what is operation 1. So for that we can see that what are the various description. That description can also be added as an appendix to the operation process chart wherever possible. And if you go back, refer back to our previous example that we have taken, if we go back to our previous example, the operations were also mentioned along with the operation process chart: turning, inspection, drilling, assemble fan, die cast. So wherever possible we can add a word or two related to the detailing about the operation and inspection. coming back to again, but here there are large number of operations and inspections taking place, so we can have a separate appendix for that. So here you can see the operations. So quickly we will see that what are the various operations. Operation 1 is face, turn, undercut and part off on a capstan lathe. Even the detail on which machine the operation has to be done is also given, and if you see the time required is also given. So we know that now operation number 1 in case of our spindle will be done on capstan lathe. What are the various operations we have to do? Facing, turning, undercutting and parting off, and the time required is given. Operation 2, face opposite and on the same machine. Another operation, same machine and the time required is given, which is also operation. After this operation, the work is sent to the inspection department for inspection 1. Inspect for dimensions and finish. So as we know, in inspection we will try to compare the output in terms of certain standard output or the specifications. So that is, we will try to inspect for dimensions and finish. So no fixed time is allocated here, that we have already seen. From the inspection department, the work is sent to the milling section. So now we see whatever has to be done on the capstan lathe has been done in operation 1 and operation 2, then it has been inspected. Now it is going to the milling section. Now the next operation, third and fourth, will be carried out. Now operation 3, straddle mill 4 flats on the end on a horizontal miller. So horizontal milling machine is used, time is also given. Then remove the burrs at the burring bench, the time is also given. The work is returned to the inspection department for inspection 2, final inspection of the machining. So what we have done, we have used a capstan lathe machine and we have used a horizontal milling machine to perform certain operations, and these operations we have represented in our operation process chart with a special, not the special but the important operation chart symbol, that is process chart symbol for operation, that is a circle, and inspections have been depicted by squares. Now the inspection 2 takes place. You can see this was done on capstan lathe, inspection, straddle milling of 4 flats, then deburring was there, remove the burrs at the burring bench, and this is the inspection of the machining. Now from the inspection department, the work goes to the plating shop. So now the 5th and 6th operation will be related to the plating section. So operation 5 you can see is degreasing, the time is also given, and operation 6 is cadmium plating. So operation 5 is degreasing and operation 6 is cadmium plating. After that, from the plating shop, the work goes again to the inspection department. So we have seen 5th and 6th is, this is degreasing, this is plating, and finally this is the third inspection that is taking place. So this way we can see, we can observe, we can correlate that this is going to be the operation and this is going to be the inspection. That is very easy. So then we can plot the main component, and for the sub assemblies also we can follow the same process, and then we can see where the sub assembly is going to be added into the principal component. So in our case, the principal component is the spindle, and there are 2 other parts which have to be assembled in this to make our final product. Now the plastic molding is supplied with a whole board concentric with the longitudinal axis. So then this is the basic condition in which the plastic molding is available. Operation 7, face on both sides, bore the cord hole and ream to size on a capstan lathe. Again the machine and the operation is highlighted, time is also highlighted here. Operation 8, 7 and then 8, drill cross hole for the stop pin and burr on 2 spindle drills, press. So the machine is again highlighted, 2 spindle drill press, and the cross hole, drill the cross hole, the operation is also. So we have the what operation is being done, on which machine it is being done, and how much time it is taking is highlighted. Now from the drilling operation, the work goes to the inspection department, and the 4th inspection will now be carried out. Now final check of dimensions and finish is done, that is the inspection 4th. It is then passed to the finished part stores to await withdrawal for assembly. Now this is, you can see the complete picture. This is a plastic molding, and this is a spindle. Already we have discussed. It will be seen from the chart that the operations and inspections on the molding are on a vertical line. So operations and inspections on the molding. Now this is a molding, so these are the 7, 8 and 4 are the operations and inspections being done. This is operation, as we have seen. The machine was also mentioned, this second operation, and one inspection is being done, that is inspection number 4. Again, just to revise, we can see there are two operations, 7th and 8. So 7th is face on both side, 8 is drill cross hole. So both these operations 7, 8 and inspection 4 are being done on the plastic molding. Now this is because the molding is the first component to be assembled to the spindle. So this is the first component. If we see, this is getting assembled to the spindle. This is our spindle line. The operations and inspections being done on the spindle. So this is now finally getting assembled to the spindle. Now the stop pin is set farther to the left. Stop pin is set farther to the left. Now this is the left direction from the spindle. The stop pin line is set farther to the left, and if there were other components, they would be set out from right to left in order in which they were to be assembled. So if there are more number of components, so here we have one spindle, one plastic molding and one stop pin. So suppose there are other two components also which have to be assembled to the main spindle, and they are as per their sequence of assembly, we will make their lines here towards the left hand side, and they will finally come and get assembled like this to the main part or to the principal part. Now this is assemble the molding to the small end of the spindle and drill the stop hole through the hole right through. So this is the, you can say, one operation. This is the operation number 9 which is given here. So this plastic molding, as we have already discussed, after the two operations being done and one inspection done, comes and gets assembled to the main spindle here, and then one operation is done, that is operation number 9, and operation number 9 is assemble the molding to the small end of the spindle and drill the stop pin hole right through. So we are doing assembling and then drilling the stop pin hole. So this is one operation, we are drilling the hole through hole. Now once this has been done, the assembly is ready for the insertion of the stop pin made from 5 mm diameter steel rod, which has been made as follows. Now if we go back, this is the stop pin. Now up to this we have seen the spindle, what are the operations and inspections we know, plastic molding, what are the inspections and operations we know. Finally it has got assembled, then final operation has been done, that is operation number 9. Now we focus our attention on the stop pin. Now for stop pin also, how many operations are there? 1, 2, 3 and 4. So we have 4 operations for the stop pin and 2 inspections for the stop pin. So what are these 4 operations and 2 inspections, that quickly we will like to see. So after inspection, the work this we have already seen. So now coming on to the stop pin, 10, 11, 12 and 13 operations we need to understand. So let us see now what are these 3. Once this has been done, the assembly is ready for the insertion of the stop pin. So let us now focus on stop pin, and this is giving us the vertical line related to the stop pin. Operation 10, turn 2 mm diameter. So operation is given 2 mm diameter shank, chamfer and another work, parting of another work. So this is one operation. Turn 2 mm diameter shank, chamfer and part off on a capstan lathe. The machine is also given and the time taken is also mentioned. So what is the operation or combination of operations, on which machine and for how much time. Then operation 11 is remove the pip on the linster, the time is also given. Then the work is taken. So 10 and 11, 10 is done, which involves chamfering off, first turning, chamfering off and parting off. Then 11 also mentioned, removing the pip from the linster, and then we pass on to the inspection. So this is the 5th part, that is inspection. Inspect for dimensions and finish. After that, now we have to go to the 12 and 13 operation. Operation number 12 is, again we have seen earlier also, operation number 12 degreasing, and operation number 13 is cadmium plating. The time required is also given. So after inspection, the work goes to the plating shop. The work now goes back to the inspection. So we have done degreasing, we have done cadmium plating. Now the 6th inspection is taking place, that is the final check. So now we have seen there is a main part, what are the operations and inspections, then the molding, what are the operations and inspections, then for the stop pin, what are the operations and inspection, and finally this will be assembled to our main part. Now our main part or the principal part has now already the molding assembled into it. So this molding is already a part of the main part. This is the main spindle, this is the molding, plastic molding, and now finally the stop pin is getting assembled here. And after that there is operation number 14 which is mentioned here. Now what is operation number 14? We can see operation 14, stop pin is fitted to the assembly and lightly riveted to retain in position. So it is riveted to retain it in position. Time is also given. So after assembly, the operation number 14 is done, and last 7th inspection it is there, and the 7th inspection is related to the completed assembly is finally inspected. It is then returned to the finished parts stored. So finally we are able to complete our assembly of the 3 important parts. The principal part is the spindle, then the plastic molding and the stop pin. So we combine the 3 parts together and it is sent to the finished goods stores. So this way we can draw the operation process chart for any complicated assembly also. So we can see that if we understand the processes, if we understand that where the process is taking place, where the inspection is taking place, very easily we can depict the complete maybe gambit of processes into and inspections into one very concise, precise, easy to understand chart. And this chart is now, maybe this chart is a A4 size chart, but is going to give us a complete picture of all the operations, inspections as well as the sequence that is being followed to perform the work. What we can gain out of this? We can see that how much time is taken for individual sub parts, that is one thing. How many operations are taking place, how many times we are inspecting, then we can try use our creativity to come up with alternatives which help us to achieve the objective of making this final product, but with lesser number of operations, with lesser number of inspections, with less time required, with less manpower required. So once we have properly documented, recorded the current method of doing the work, then we can brainstorm, we can discuss among ourselves, we can look forward to developing a better method of doing the work. So with this we conclude the today's session on operation process chart, and we have seen 3 examples that how we can construct operation process chart. In our subsequent sections and sessions in method study, as you all remember that we have 4 weeks of discussion on method study. So we will be focused on other important recording techniques that are used for performing the method study. Thank you.